like be it substitution or be it using eliminate. Hey folks, welcome to my channel number pen. So there we have the problem on our screen. Integrate the following with respect to x. And then we've been given four functions: x to the power 11, 1 by x to the power 7, cube root of x to the power 4, x to the power 5, the whole power 1 by 8, right? So far we've been doing problems on differentiation where we've been asked to find the derivative of functions. Now, from this video onwards, and this is the first video in integral calculus, and we'll start off with a very simple problem, which is what you have on your screen. We will learn how to integrate functions with respect to x, right? So before we jump into solving this particular problem, what does integration actually mean? Let's write it like this. I know that many of the textbooks have very good explanations of what we mean by integration of a function. So it's nothing but integration and differentiation are inverse functions, right? So when you're being given a function and asked to integrate it with respect to x, what is it that we've been given? We've been given dy by dx, right? And earlier in problems around finding derivatives or differentiation, we have been given y and we've been asked to find dy by dx. In integration, we've been given dy by dx and asked to find y, right? And we've got specific names. When your dy by dx equals a function, then that function, let's say it is f of x, right? Let's say this function is f of x, and you've been asked to find y in this equation, right? Let me write it down like this. My dy by dx, let me call it say f of x, and my y is going to be my g of x, right? In the world of integral calculus, we call y as the antiderivative of f of x, right? And then we call f of x as the integrand. And this process of finding y is often called integration or sometimes even antidifferentiation, right? And we call this particular process as Newton-Leibnitz integral, right? And we use the integration symbol, which is denoted by this symbol, right? This is the symbol that we use for integration. So when I write my dy by dx equals f of x, what it actually means is my integral f of x dx is equal to g of x, right? So this is what it means, right? So let's go back to the problem. My dy by dx equal to x to the power 11, right? So what happens is I've been asked to find y. Integral of x to the power 11 dx equal to y. And this is how we write this particular expression, right? So we've been asked to find y. Let me put y on the other side. It's much more easier to visualize it that way. Now I want you to understand how do we arrive at y, right? Now we go back to what we learned in first principles, right? Now I know that my d by dx of x to the power n is nothing but nx times x to the power n minus 1. So this is what we have from first principles. D by dx of x to the power n equal to n into x to the power n minus 1, right? So what is that function which when I differentiate will give me x to the power 11 is what we have been asked to find, right? D by dx of x to the power n divided by n equal to x to the power n minus 1. And then I also want you to remember that the d by dx of any function, whenever the function is a constant, is a zero, right? So for my dy by dx equal to x to the power 11, I can have many antiderivatives. Why is that? Because of this, right? D by dx of x to the power n divided by n is equal to x to the power n minus 1, and at the same time d by dx of x to the power n divided by n plus c, where c is any constant, is also x to the power n minus 1, right? So for the same function which is called the integrand, we can have many antiderivatives, right? That is what it means. And all these antiderivatives are different from each other by this particular constant. And why is that? Because dy dx of a constant is 0, right? And therefore, my d by dx of x to the power n divided by n plus c, where c is any constant, equal to x to the power n minus 1 means what is my antiderivative for the above function? I go back to my y, and what is my y now? When I say y, I will have to figure out what is it that is highlighted here in yellow. I have been given the expression which is in green, right? So the green expression in our case is x to the power 11, and we've been asked to find the yellow expression for us, right? And what is that y, which is antiderivative of x, right? So I have y equals integral of x to the power 11 dx, and when I apply this particular formula, what do I get? I can replace my n by n plus 1 here, right? And when I do that, I will have to make sure that I do this, right? Wherever I have a n, I replace it by a n plus 1, which means my green expression becomes x to the power n. So when x to the power n equals x to the power 11, what is my antiderivative? It is nothing but x to the power x to the power n plus 1, again referring to the yellow expression which we have highlighted, and x to the power n plus 1 is nothing but 11 plus 1 whole divided by, again I have 11 plus 1 plus c, which means our answer is x to the power 12 plus c, right? So this is our final answer. Let me highlight it in pink. X to the power 12 divided by 12 plus c. And a quick way to check if your answer is right is to differentiate this particular expression and check, right? So let's assume we differentiate this answer, what we have, x to the power 12 divided by 12 plus c. I again apply first principles. I know that x to the power 12's derivative is 12 into x to the power 11. I can cancel out the 12 on the numerator and in the denominator, and then my d by dx of c constant is a 0, and I'm left with x to the power 11, right? So that's how we go about solving these problems. And I want you to remember this particular expression, d by dx of x to the power n plus 1 divided by n plus 1 plus c, any constant, equals x to the power n, right? Which means that my antiderivative of x to the power n is nothing but x to the power n plus 1 divided by n plus 1 plus c, right? Right now, let's go to the other problems which seem to be a very similar type. And I'm going to pull out the second one, which is 1 by x to the power 7, right? Again, we have a very similar, let me call it 2, right? 1 by x to the power 7, right? And what is that? If I put it back in the x to the power n format, all that I've been given is x to the power minus 7, right? And what is my antiderivative? My antiderivative is x to the power minus 7 times dx, right? So again, I apply this formula what I have above, x to the power n plus 1 divided by n plus 1. And what is my n here? My n is minus 7. X to the power minus 7 plus 1, which becomes a minus 6, whole divided by n plus 1, which is again a minus 7 plus 1, which is a minus of 6, right? So which means I'll pull out my minus sign. This is what I have as my answer to second problem. Minus the x to the power minus 6, the whole divided by 6 plus c, right? So again, differentiate it on either side and see if you're getting back your x to the power minus 7, which was your original integrand, right? So x to the power minus 7 is your integrand. Your minus x to the power minus 6 divided by 6 plus c is your antiderivative for this particular function, right? Now let's go to the third problem. Our third problem is cube root of x to the power 4, right? Now, what do I mean by cube root of x to the power 4? My function is nothing but x to the power 4 by 3, right? Here I have a function which is very similar, and I know that I can apply formula that I learned just now. My y equals integral of x to the power 4 by 3 times dx, and again I apply the same formula, which is x to the power 4 by 3 plus 1 whole divided by n plus 1. Again, my n is 4 by 3. I get a 4 by 3 plus 1 in my denominator as well. And then remember, folks, in all your answers, do not forget to mention the constant, right? See, so what happens to my numerator? It is x to the power 7 by 3 whole divided by 7 by 3, which means it becomes a 3 by 7 plus c. I can rewrite it as 3 by 7 times x to the power 7 by 3 plus c, right? So that's the answer for this particular problem. Again, just reminding you that do a quick differentiation of these problems to ensure that your final answer is right. And it's definitely possible whenever you have simple problems such as these, right? 4, we go to the final problem here. X to the power 5, the whole divided whole power 1 by 8, which is nothing but I can apply the this is what I have, and again I apply the same formula, x to the power 5 by 8 plus 1 divided by 5 by 8 plus 1 plus constant, and when I simplify this, what do I get? I get 8 by 13, 8 by 13 times x to the power 13 by 8 plus c. Right? So let me highlight the final answer in pink. 8 by 13 times x to the power 13 by 8 plus c. Right? So that's how you go about figuring the antiderivative of a function which is being given to you. And I hope you found this content useful. In our upcoming videos, we'll do a lot more problems on integral calculus. Stay tuned to my channel, Number Pen. Thank you for your continued support and have a good day.